Hello everyone, welcome to Piezo Physics. I hope you people are doing well. In this particular video, we are going to learn about thermal expansion. Last time we saw that due to linear expansion, how length increases with increase in temperature, right? Right now we will see stress in the object due to thermal expansion. Consider one linear solid between two rigid clamps, right? Initially its length is capital L and it is at temperature T, right? Now, if we is now if we increase its temperature by delta T, so it will expand, right? So the change in its length will be delta L, right? That will be directly proportional to alpha into L into delta T, right? Now, as we know, it will increase its length, and due to two rigid clamps, there will be some stress on this linear solid, right? If linear cross section of this particular linear solid is A, then stress will be equals to force due to this linear solid divided by area of cross section of this linear solid, right? And strain will be directly proportional to delta L by L, which will be equals to, from this formula we can write it as alpha into delta T, right? Now as we know, Young's modulus Y equals to stress upon strain. So if we put these both the values, we will have Y equals to F upon A divided by alpha into delta T. Therefore force will be equals to Y into A into alpha into delta T. Therefore force will be equals to Y alpha A into delta T. So that is the force due to thermal stress, right? So this is our main formula for stress due to thermal expansion. Now let us solve one numerical based on this theory. We have a steel wire of cross-sectional area of 0.5 millimeter square. So capital A equals to 0.5 millimeter square. So it will be equals to 5 into 10 power minus 7 meter square. Is held between two rigid clamps so that it is just taut at 20 degrees Celsius. Initial temperature is 20 degrees Celsius. Find the tension in the wire at 0 degrees Celsius. So T final is 0 degrees Celsius. So change in temperature is 20 degrees Celsius. Given that Young's modulus of steel is 2.1 into 10 power 21 dynes per centimeter square, right? And coefficient of linear expansion is given, which is 1.1 into 10 power minus 5. We have to consider it into centimeter square as we have Young modulus into centimeter square. So it will be 5 into 10 power minus 3 centimeter square. As we know, tension or force F equals to Y alpha A delta T. Young modulus we do have 2.1 into 10 power 12, right? So 2.1 into 10 power 12 into alpha we do have 1.1 into 10 power minus 5. Area of cross section is 5 into 10 power minus 3 and delta T we do have 20, right? 5 into 20 will be 100, right? So 10 power 12 plus 100 will be 10 power 14 minus 8, and 2.1 into 1.1 will give us 2.1 into 1.1 will be 2.31. So it will be 2.31 into 10 power 6 dynes. It will be ultimately 2.31 into 10 power 1 Newton. right? So this is our problem related to thermal stress.